Hi folks, welcome back to Physics with Captain Rod. The purpose of this video is to demonstrate how to use trapezoids in Microsoft Excel to estimate the area bound under a curve. So what we're going to do here is we're going to look at the curve y equals x squared plus 3, and we're going to try to estimate the area bound between x equals 1 and x equals 4. Now I've already drawn in some of these trapezoids here, so here's the first one, and then the second one, and the third one, and so forth. I usually draw 2 or 3. That's enough to usually to get me going and writing equations. Now, what I usually do, start by giving these things names. They're like people. They want to have a name too. So we're going to call this the first trapezoid, the second trapezoid, the third, and so forth. Now, you'll notice at this point, once you're giving them numerical or assigning them numerical values, you've basically introduced a new variable here, and that's what's called a dummy variable. And I wrote that right here. I called that variable I. So we've got the I equals 1 rectangle, the second, third, down to n of them. Now I'm going to choose n equals 10 again because that's plenty to demonstrate how to do this. But again, if you wanted to use 20, 30, or even 100, that would work just fine. Now, to get the area of a trapezoid, what I'm going to do is I'm going to treat it like a rectangle that looks just like this. That's not too bad. Imagine a rectangle that goes right through there where the function touches it right in the center. Just like in my previous video, if you saw that, where I use what I call the Goldilocks method. If I take this rectangle and I cut this piece out and glue it right there, it has the same area as the trapezoid. And the area of a rectangle is length times width. The only kicker is we're going to need to calculate the length. Now you'll notice that the length is longer than the short side of the trapezoid, but shorter than the long side of the trapezoid. In fact, it's right in between them. It's the average of the two. So we're going to need these distances. So I gave these distances names. I called this one L sub I for left-hand side of the ith rectangle. And this guy right here I called R sub I for right-hand side of the ith rectangle. Now, in order to get these, we're going to need function values. To get the L sub i's, we're going to need that function value, this one, and so forth. Now, I already wrote down how I'm going to do that. Let me explain it. So the x sub L, I'm starting at my lower bound A. Now, if I tacked on an I times delta x, look at what would happen. Like imagine I start at A and I tack on 1 delta x. That puts me there at the right-hand side of the first rectangle. If I tack on 2 delta x, that puts me here, right-hand side of the second rectangle. All right, that's not where I want to be. I don't want to be on the right-hand side. Notice in both cases, I got to go back to the left, a delta x. So it isn't I times delta x that I need, it's I minus 1 times delta x. This formula here should put me at the left-hand side of every rectangle. The original one here, a plus I delta x, will put me at the right-hand side. All right, this quantity right here will put me at the right-hand side of each trapezoid. I think I said rectangle a minute ago. I meant trapezoid. All right. Another thing I'm going to need the function values, right? So L sub I here is going to be the function value there. So what I call f of x sub L here, that's L sub I. And then function value at x sub R, that's what I called R sub I here. The thing is, this is how we would get them in this example, by computing function values at the appropriate locations. All right, what I'll do is I'll have Excel calculate all of these. Then what I'll do is I'll calculate the area of each trapezoid by taking L sub I plus R sub I over 2 and multiplying it by delta x. That should give me the area of each trapezoid, and then we'll sum them up. So let's go over here to the right and see what that looks like. Now I already have some of this done here to try to keep this a little on the shorter side. So if you've seen my videos on how to do, or anybody else's videos for that matter, how to do use Excel to calculate areas here, I calculated, well, these I just did by pattern. I listed off 10 of them. And then the L sub I, here's my formula for it. You'll notice I started at A, and it's double dollared, plus I minus 1 and then times delta x. So there's how I got my L sub i's. Very similar method here for the R sub i's. And again, there's where I put in the formula, a plus I delta x. So there's my A plus I delta x. And again, these are double dollar because they're over here and we don't want these to scroll down. Okay, next I've got to calculate the L sub I. To do that, I need the function value at the left-hand side. So that's these guys. So I'm going to come over here now and put in, whoops, I see that I didn't quite label this quite the way I wanted. Hold on, I'm going to go back here. I had intended on calling that XL sub L sub I. All right, X value that gets me the appropriate location there at the left-hand side. This guy I had intended on calling XR sub I, X value that gets me the right-hand side of the ith rectangle. Okay, sorry about that. And then here, let's see, now I'm going to calculate L sub I. And that's going to equal my function value at this X location. So that's going to be this guy squared plus 3. And we'll grab, do all of these. Okay, then I'm going to want the R sub i's. And here I want function values at the right-hand side. That's going to be these function values. So I'm going to take that, square it, add 3. Grab, drag. Okay, this stuff, I'm sorry, I should have cleared this. That was previous work from before. All right, A sub i's. Now I'm going to get this from the left and right-hand side of the trapezoid. So this is going to equal. Now what I want to do is average the left and right-hand sides. So we're going to take this plus this, divide by 2. That's the average height of the trapezoid times the width of the trapezoid. And again, you got to double dollar that because you don't want that one to move when I do my drag math here. Grab, drag, there's all of them. Okay. Now, I had this set up from previous work here, but the idea to get the total area, what I did is I summed up everything in this column. So you can just type, hit equals, that tells Excel formulas coming, and then sum up, and then you just grab these and highlight them. 30.045. Now, I just made a video probably 10 or 15 minutes ago where I did that by Goldilocks method, and I think I had about 30 in that example too. So you can use either method. The trapezoid rule probably technically is a touch more accurate method, but I find that the Goldilocks method for if you only need 2 or 3 sig accuracy works perfectly well for a lot of examples. Trapezoid method also a very good method. So I hope this video helps demonstrate how to use Excel and the trapezoid rule to calculate areas. Have a great day.